Hello, everyone. Welcome to today's workshop for the Chain Abstraction Hackathon. I'm going to invite Mislav from Klaster onto the stage. Here is his Twitter as well. Facebook in the chat. Hello.
Hello, everyone.
Great. Well, we can go ahead and start the session. And let's try sharing the screen as well, or then I will leave the stage to you.
All right, here is screen sharing. I think it works.
Yeah, perfect.
All right. So, hello everyone. I'm Mislav from Klaster, and I'm happy to present today to you how to achieve chain abstraction and many other interesting things through a concept that we call transaction orchestration. So in order to get started, I'll just say that there are a couple of unique approaches to chain abstraction. So there is no one size fits all, and the approach that Klaster has taken is called transaction orchestration. In the simplest words possible, transaction orchestration means being able to execute multiple transactions on multiple blockchains with a single off-chain signature. So basically, you give a permission to cluster nodes to execute some things on your behalf, and then they do it. But the cluster nodes never take custody of your funds, and they are only able to execute things which you explicitly tell them to execute. So one of the ideas that we will be introducing here is an idea of smart contract accounts. And so we will start this entire workshop assuming that like you have only worked with EOAs, with classic, VM, Ethers.js, MetaMask stack. And so this will be like our initial assumption. So let me just share my screen. So I will show you what you can expect to be built with products such as Klaster. So this is an application that we call chain abstracted Aave. So basically, it's a version of Aave which interacts with classic vanilla Aave contracts in the background. And basically, this application works on multiple chains as if they're a single chain. You can see here, I have a USDC balance, and it says 65.68 USDC. When I open it, you can see I have some on Optimism, some on Base, some on Arbitrum, some on Polygon, a little bit on Scroll. And basically, the application treats all of the funds as if they're on a single chain. The application also takes a look at the Aave savings rate and finds the best savings rate on all of the blockchains. And essentially, what the application does is it will move your funds automatically in the background to the chain where you want them to. And in this workshop, I will teach you how to build this type of applications. So just to do a short demo, we can see that on Polygon, we have 29.99 USDC. And now I'm going to try to supply, let's say, 35 USDC, which is more than I have on Polygon. Usually, I would not be able to do this, but with Klaster, I simply click confirm. And I get a window, MetaMask window, to sign this message. So this is the message that is permitting the Klaster protocol to execute multiple transactions across multiple blockchains on behalf of the user. So I click sign, and I will get a confirmation window. I open the Klaster Explorer. So this is another one of the tools that Klaster has in our stack, where you can track the progress of these transactions. So while these transactions are being executed, I'll give you a hint on what is what in the Klaster Transaction Explorer. So here you have your interchain transaction hash. So what is an interchain transaction? So we'll go here, docs.klaster.io, and you can see that an interchain transaction is a Merkle tree of multiple transactions, which can be on one or multiple blockchains. So you can see here that this single transaction inside itself contains, let's say, pay for gas with staked ether on Arbitrum. So one of the things that Klaster also enables is gas abstraction. You can pay for gas in USDC, USDT, Link, staked ether, Matic, and many other tokens. And this works by default. No paymasters required, no setup required. This just works out of the box. So beyond this, it contains an action to bridge USDC from Optimism to Base. And then when this USDC arrives from Optimism to Base, it swaps USDT for USDC and then supplies that USDC to Aave on Base. So this is essentially what's happening here. We can see here, let's go to Base Scan, that the Klaster SDK deducted, and we will learn in this workshop how this can be programmed, deducted that there was not enough funds on Polygon to supply the entire 30-something USDC that I wanted to supply. So the Klaster SDK bridged 5.014759 USDC from Base onto from Base onto Polygon, and then once those funds arrived on Polygon, it executed a function to supply to Aave, and I have received USDCN. If I go back to the Aave example here, you can see I have 0 supplied. I refresh it now, and I have 34 supplied. So essentially, what you can see here, that with Klaster, you can build apps which basically treat all of the blockchains as a single execution environment. Why would you want to do this? Well, you can offer your users a much better user experience. So when they land on your page, they can deposit funds on any blockchain. They can move funds around from any blockchain to any other blockchain, and it will all be invisible to them. As far as they are concerned, all of their funds, all of their balances are single balance. All the deployed Aave instances on all of the blockchains are a single Aave instance. So this is essentially what we are trying to achieve with Klaster. Now, I won't be going too deep in this workshop in the, let's say, supplying to Aave or certain things like this. I would assume that you already know how to do this. So basically, this workshop assumes that you already know how to encode blockchain actions. But we will be going through the entire process of encoding these interchain transactions, executing them, setting certain tokens as gas payments, and interacting with bridges. So one of the cool things about Klaster is that you can access all the best, fastest, most highest quality sources of liquidity instantly through Klaster. So this concrete example is using Li-Fi and Across. In our demo, we will be in this tutorial, in this workshop, we will be using also Across, but you can use any bridge that you like. We also recommend using bridging aggregators such as Li-Fi, and then you can, mix and match things. But Klaster SDK is essentially built to make these bridging interactions and multi-chain interactions as easy as possible. So I can see that we have no questions, so it's just comments. Hello, everyone. Glad to have you here. So yeah, let's get started. This is going to be a very hands-on tutorial. We will not be essentially going through some slide deck or something. As we encounter new concepts, we will be exploring them, and I will be explaining what they do. So in order to get started, I just wrote this essentially initially to test it out. But what we will be doing here is creating our first interchain transaction. So in order to do this, you need a private key, or you need to connect your app to MetaMask, or however you want to do it. Right now, I will be using a very simple TypeScript environment where you can do this very simply. So this is my private key. There's maybe like 10, 20 USDC there, so please don't steal it. But yeah, if you do, I won't be super mad. So what we will be doing right now is simple one-chain transaction. So we will start very, very simple. One chain, one transaction. And how do we do this with Klaster? So initially, what you need to do, you need to initialize the Klaster SDK. So let's say Klaster and say await and call it init Klaster function. So this is your starting point, this init Klaster function. It takes an object that has two variables. So one is the node URL. Well, luckily, Klaster exposes for you the default RPC endpoint for the Klaster node, so you don't have to do it yourself. And then account init data. So one of the big things about Klaster is that it works with smart contract accounts. You can see here, basically, that Klaster right now in this iteration supports Biconomy and Safe accounts. But you will also be able to use ZeroDev and all the other providers. We are adding them one by one as we are developing the SDK. If you don't know about smart contract accounts, basically they are accounts which are smart contracts, obviously, They are based on this standard called ERC 4337, and the core idea of that standard was account abstraction. The idea was to enable users to pay for gas with USDC, USDT, or some other token. The idea was to be able to batch transactions, so execute multiple transactions, such as the infamous approve plus execute transaction on ERC20 tokens. So this grand idea essentially was to enable abstraction. Well, Klaster takes this abstraction a step further, making it multi-chain account abstraction, or as you like to call it, chain abstraction. It does this by being able to leverage these smart contract accounts to execute multiple transactions on multiple blockchains. And we'll see how this is done until the end of the tutorial. So let's finish initializing our Klaster SDK. So what I will do now is I will call load Bico V2 account. So this is the Biconomy V2 account. And so a Biconomy V2 account has an owner. An owner is an EOA, so either a MetaMask account or an account derived from the private key. I'm here using the VM private key to account. So as I said, this is my private key. So I have access to this account. So I will say the owner is account.address. And this is it. Basically, I created my instance of the Klaster SDK. You can see this is Klaster SDK with the type Biconomy V2 account in it data. So this is a Biconomy flavored instance of Klaster. So what we will do next essentially is encode our first transaction. So the cool thing here is Klaster doesn't require any type of fancy transaction types or anything. You just work with your normal transactions. And we'll call this one send USDC transaction. And so we'll just call this helper function from Klaster called rawtx. You go here and you say, look, we are sending to, let's waste some money, sending to 0 address. And then, look, actually, let's send to account.address. So one of the things that's very important to see here, to note here, is that Klaster will create a separate address from the one from your account, just like every other smart contract account provider. You can fetch this address by going Klaster.account.getAddress. And you can see with this account.address, it's the same address on all of the blockchains. Well, Klaster, it's almost the same address on all of the blockchains. So you will have the same address on Optimism, Base, Arbitrum, Ethereum, Mainnet, Polygon. But unfortunately, the ZK Sync stack doesn't derive smart contract accounts the same way as Klaster. So on their stack, you will get a different address. But let's say for now, we will only be working with Optimism, Arbitrum, Polygon, and those who all have the same address. So I'll call this constant, let's say Klaster account address. And I'll say Klaster.account.getAddress, and I'll get it from Optimism. And it will be, as I said, it will be the same address on Optimism, Base, Arbitrum, Polygon, etc. So we are now sending from this Klaster account address. Before you start, you need to fund this address with a little bit of USDC, let's say, or USDT, or ETH, or whatever you're going to be using. So this address needs to have some funds on it initially. So let's say we are sending now this USDC to account.address. So this is the address of my EOA, right? So these are two separate addresses. I'm repeating this because it's a very, very important distinction here. So we will be putting the gas limit, I don't know, at 90,000. And the value being sent will say parse units. Let's send 0.1 USDC. USDC has 6 decimals, so this is how it will be working. I will show you later how to deal with multiple instances of the same token on multiple blockchains. So, okay, so we have our transaction ready. You see, it was as easy as that. What we need to do now is build an interchain transaction. This is this cluster transaction that I was telling you about. And we have a useful helper function called build ITX. We open this build ITX, we say steps. So steps is an array of multiple transaction batches. So to explain this a little bit. So in normal account abstraction, you can execute multiple transactions on a single chain. But in Klaster, you can execute multiple transactions on multiple blockchains. So each step is all the transactions you want to execute on that specific chain. So let's say we now have only one chain, so it will be only one step, and this step will be a single transaction on Base because I have funds on Base. I didn't say this earlier. I pre-funded my Klaster account address with money on Base, and I will send USDC. So, and this is my interchain transaction. Now I need to specify how I'm going to pay for gas. So I can do this by saying fee TX and going to Klaster dot encode payment fee, and then I will say I will pay for this transaction on Base with USDC. And so we encounter another very important concept in Klaster is you can pay for transactions on another chain. So for example, you can execute a transaction on Optimism, but pay for gas on Arbitrum, or execute a transaction on Polygon, but pay for gas on Base. So this is very important. Klaster supports multi-chain gas abstraction, which is a very, very useful concept. As you saw in the chain abstracted Aave demo, we actually paid for gas with USDC on Optimism, but executed a transaction that involved Base and Polygon. So multiple chains, multiple blockchains. It's extremely simple with Klaster. So now what you need to do, you need to get a quote from the Klaster node. So a quote is basically a commitment from the Klaster node that they are willing to execute this ITX that you prepared. You do this by saying await, and then calling Klaster get quote, and you simply pass this ITX as a parameter. It's as simple as that. Now, when you receive a quote, you will receive an interchain transaction hash. The Klaster system needs the user to sign the interchain transaction hash with their private key in order to permission the system to execute these transactions. So the Klaster system is fully trustless. It cannot execute anything that the user has not explicitly approved. And this is validated on the level of smart contracts, right? So there is no way for you to essentially, for the Klaster system to steal your funds or do anything. It never takes custody of any funds, and it can only execute the things that you put here in this ITX after you have signed them. So now I will go to, I will create a variable called signed, and I'll say await account. So this is my EOA account. So I am signing with my EOA account, which is again different from my Klaster account. Sign message. This is your classic, you know, if you worked with VM ever, this is account.sign message. If you were working on web, it would be client.sign message if you were working with like MetaMask or whatever. And so I will say here, you will have to pass the message object, but you will have to say it's a raw message. Because of the way the Klaster decodes and encodes transaction, you have to pass this raw parameter within message if you are using VM. If you are using Ethers or other frameworks, you can do this in different ways, but basically it's very important that you sign a raw message. And we will say quote.itx hash, and this will now basically give us a signed interchain transaction hash. So signed hash of this transaction. Once we have signed it, we simply say, okay, let's have a result, and we say Klaster await Klaster dot execute, and we pass it the quote that we got from the node, and then we also pass it the signed ITX hash. And yeah, now we can simply console.log result.itx hash, and we will basically execute this. So you can see this is in a function called start, and we basically call this start function here. So what I'll do is I say bun run.index.ts, and voila, we have our signed interchain transaction hash. I will go to explorer.cluster.io. I will paste this transaction hash and see my transaction is now being executed. We can go to base scan and we can see that this transaction is essentially sending basically 0.1 USDC to some address, and the gas is being paid. We can see this here. Gas is being paid in USDC on base. So this is our simplest possible interchain transaction. Now, what we can do here, I only have funds on Optimism here on this Klaster account address. But let's say I want to execute like an empty transaction. I'll say empty TX. I'll say raw TX, and 2 will be 0 address. Gas limit will be, I don't know, what was like the minimum was 70,000. And then I will pass value 0. So this is a transaction that basically does nothing but execute itself. But I will be using it now to demonstrate to you that you can simply, as simple as this, add single tx optimism.id and say empty tx. So what this will do now, it will again send a little bit of USDC to a random address. It will execute this empty transaction on Optimism, and it will pay for the gas fees with USDC. But just a note, this empty transaction on Optimism could have been any other transaction. So what I'll do here now is I'll run it again, wait for the transaction to execute, basically for the node to accept my quote and start executing the transaction. I'll go here, back to my Interchain transaction hash, click search, and I think I got the old one, optimism.id, empty transaction. Let's just see why we're not seeing multiple chains. Did I copy the new one? Okay, it's showing me the old transaction, but let's try it one more time. Otherwise, we'll continue with the tutorial. Maybe it's not accepting the empty transaction for whatever reason. Here it is. So we were basically pasting the old transaction. So what basically I wanted to demonstrate here is that now you have, with this simple piece of code, so like excluding initializing accounts and everything, this has maybe 10 lines of code. You have successfully executed a transaction on Base, a transaction on Optimism, paid for gas with USDC on Base, and it was as simple as that. Now, executing like multiple transactions on multiple blockchains is cool, but you know what's even cooler is sequencing those transactions. So do something on Base, bridge funds from Base onto, let's say, Optimism, and then do something on Optimism when those funds arrive. And this is exactly what I will be demonstrating to you now. So in order to do this, we need to create a bridging plugin. But before we can create a bridging plugin, we need to introduce a concept called token mapping. As you all know, tokens don't have the same address on all of the blockchains. So what we need to do is we need a way to tell the Klaster SDK which address this token has on which chain. We will now be working with USDC, and you can go here to USDC deployments, and you can find all of the addresses of all of the USDC tokens on all of the chains. So right now, let's say we will be using Base, Arbitrum, and Optimism, right? So we need a 3-chain token mapping. The easiest way to do this, Klaster, again, SDK gives you a simple way to do it. We'll call it MC USDC. Basically, this is a multi-chain USDC, and call the function build token mapping. It takes an array of objects called token info. You can initialize these objects by calling the deployment helper function. And let's say, okay, on Base, the address of USDC is this one. So let's just copy it here. So let's also create a deployment on Optimism. So on Optimism, USDC has address, let's find Optimism, probably a little bit blind now, OP mainnet, okay, here. And then on Arbitrum, USDC has address. So now we have created a multi-chain token mapping. The Klaster SDK, whenever you pass it this USDC mapping, will know how to access every token on every chain. Now, how Klaster does this, I will first demonstrate it to you, and then we will basically play around with it a little bit. Is you encode bridging operations. You can see here, I've already written my bridging plugin, and I will explain to you how to write the bridging plugin. But this bridging plugin works for a cross bridge. So when I go here, I say bridging operations or ops, and I say encode bridging ops. So this helper function will encode a bridging operation for me. So I'll say it like this. So first of all, I pass it the token mapping. So what I do here is basically just pass it this instance of MCUSDC. Then I give it an account, which is my Klaster account, which is a multi-chain account, and then I give it an amount, and this amount, this is very important. So how this bridging plugin works is basically it says, look, I want to have a certain amount of funds on this chain. I don't care how you get it there. So for example, if you have a little bit of money on Optimism, a little bit of money on Base, a little bit of money on Polygon, and you want to send it to the Arbitrum, you would not be writing 3 or 4 or 5 bridging transactions. You would simply call encode bridging ops, and you would tell it, look, I need, let's say, parse units. So it would be, I need 3, let's say it like this. I need 6 USDC, and I can also use 6 decimals here. I need 6 USDC on some chain. So let's say you also have destination chain ID, and let's say I want these 6 USDC to be on Arbitrum. So I call destination chain ID Arbitrum. Bridge plugin, now I need to pass it the bridge plugin. As you can see here, I have already written it. It's called a cross bridge plugin here, and I simply cross bridge plugin. I simply pass it here as a parameter. Now, sometimes by passing this plugin, you might get an error that it's accessing the wrong, that this is undefined. So like this from the keyword from JavaScript. You can fix this by simply calling it like this, cross bridge plugin, and passing along data like this. So if you ever get this problem that this is undefined, you simply just call it like this and it will be fixed. Client, I need to pass it a multi-chain client. So now we get to another concept in the cluster multi-chain concepts idea is we need a way to be able to read from multiple blockchains. But the Cluster SDK wants to make this as easy for you as possible. It needs to know all of the balances on all of the blockchains, and in order to do this, you need to provide it with a multi-chain client. So just the same as we did build a multi-chain USDC, we'll do this, build a multi-chain client, build multi-chain read-only client. And so what this expects basically is a chain RPC info, which is a very, very simple object, which consists of chain ID and an RPC for this chain ID. Now, I will use VM here because I don't want to go and find RPCs, but in production, you should probably use like your own RPCs. So I'll go here, say optimism.id, base.id, and arbitrum.id, and I'll map them, chain, and then I'll just return chain ID as chain.id, just need to remove this. So chain.id, and then for RPC, I will use the fact that VM already provides you with a list of default RPCs for certain chains, RPC URLs, default, HTTP, and the first one. We'll take the first one. So this now enables the Cluster SDK helper functions to read from multiple blockchains instead of you. So usually you would have to go read how much do I have on Optimism, how much do I have on Base, how much do I have on Arbitrum. Here, everything will be done automatically for you. And you say, you pass this client, and now you have full, and you need to await this function, you have a full bridging operation that will find how many tokens you have on which chain, encode bridging operations for every single one of these actions. And this includes approve the bridge and then call the bridge function, all in a single function call. Like if you were not doing this with this function call, it would probably take you a full like file, maybe like hundreds of lines of code to achieve this. But with this, basically, you are able to do it in such a simple way, assuming that you have written your bridging plugin, which we will get into very, very quickly. So what I can do now is I said, okay, I have these bridging operations, and I'm moving to Arbitrum. So let's say we will encode a function on Arbitrum, which is called sendUSDC. So we already have this function sendUSDC, but instead of hard coding the value of sendUSDC, so we'll call it sendUSDC arb, we will say here that the value, how much we are sending, so actually we will not be sending value here, it's not ETH, we will be sending USDC. basically, so we need to encode a transaction. I think I did a mistake there. So this initial function wasn't sending USDC; it was sending ETH, right? So that was a bit different. So that was a mistake on my part. But how do you create this send USDC function? So basically, let's maybe increase the gas limit a little bit. Basically, in the data field, you simply call the normal encode function data function from VM, and you say, okay, ABI, VM exposes the ERC20 ABI, function name is transfer, and arguments are, so I think the first argument is the recipient, and let's call the recipient, okay, let's send it to the account.address, and the second parameter is the amount. And now the amount that we are sending, we will get from this bridging ops total received on destination. So not only will this function encode all of the functions for you, but it will also calculate the total amount of funds you will receive on the destination chain in order to make it easy for you to encode these transactions. So now what we will do here simply is we will sequence these actions. So we will say, look, initially I want to call bridging ops dot, so bridging ops can have multiple steps on multiple blockchains, so we need to do it like this. Bridging ops dot steps, and then we will concatenate to those steps our single transaction, send USDC arb on arbitrum.id. So now we did, send USDC arb. So now what I have done essentially is I told the SDK, find wherever you can, find USDC on any chain that you can find it, bridge 6 USDC through some optimal bridging strategy, bridge it to Arbitrum. Once those funds arrive on Arbitrum, then execute a send function call on Arbitrum. Now we have added a lot of things here. It's possible that I have made some mistakes here, that this will not work from the first time, but this is essentially how you do it. So let's run it and see if it'll work. So now it's encoding our transaction, and we got our interchain transaction hash just as last time. Say go to Explorer, paste, search, and now we see the SDK has detected that I have funds on base, and so it needs to bridge from base onto Arbitrum, and after the funds have arrived on Arbitrum, it will execute the send function. So this is essentially what we are doing here when we are executing this interchain transaction here. So one of the cool things about this is essentially that you are able to do this with as many blockchains as you want. So you can build a truly chain abstracted application where you don't really care where the user funds are. All you care is that you want this many funds on this chain, this many funds on this chain, and please supply it to this function on this chain. I have made a mistake. Now I can see it. So I wasn't supposed to call it to account address because this is send USDC. What I needed to do here, I told you, like we added a lot of things. I was bound to make a mistake. So what we needed to do here is get the address of the token on Optimism. This is very simple to do. We say MCUSDC. So let's call it like this. OPUSDC, MCUSDC. Find the token where token.chain ID equals Arbitrum not ID. So I know I have it. I can explicitly cast it, and I will say MCUSDC. So I will say here OPUSDC. So address. So OPUSDC.address. So I need to repeat this process. So this is the reason why like this transaction succeeded before this bridging operation succeeded. So one of the things I think I need to fix also in this bridge, I think I'm getting a usual very known error. I need to increase the fill deadline for cross bridge. This is something we will go through when we are encoding the cross transactions, but right now I think I just need to fix that. Okay, and so let's run it again. and we get our transaction, and we get our interchain transaction hash. We go back to our Explorer, and now we basically wait for this transaction to get executed. You can see it again has calculated that it needs to get the funds from base because I only have the funds on base, and this is the only place from where it will be fetching the funds. But yeah, essentially this is as simple as it gets. And using these simple, easy primitives, you can build applications such as Abstract Aave. So this is basically using the same exact principle that I've just shown you. So essentially it has funds on multiple blockchains. And then when you go to supply those funds, it basically checks all of those multiple blockchains, finds an optimal bridging route, and then allows you to execute this transaction. So it's a little bit slow on loading. Maybe my internet's a bit slow, but basically we already demonstrated it, and this is how it works. And one of the also demo programs that we have, and I would encourage anyone to try and build something similar to this in the hackathon, is a multi-chain disperse program, basically where you are able to disperse funds from one blockchain to multiple blockchains. So you see I have $14 on base, but what I can do here is now say send to Arbitrum 12 USDC, send to Polygon 12 USDC, etc. So I could add this as much as I wanted, and this would all get executed in a single transaction. So yeah, but while our bridging function is pending, I can take a look at some of the answers. I see Philip has a good handle of the chat. Yeah, okay, so Philip takes care of the chat in its entirety. So some of the additional concepts that we need to learn here. Basically, one additional concept that we kind of skipped over here was this across bridge plugin. So we just said there is a way to do it with across, etc. So one of the things that Klaster does, it is exposes, I'll create a new file, call it bridge demo.ts. It exposes this bridge plugin type. So I call it like this, demo bridge plugin. Sorry, I just need to remove this a little bit. And I'll say it's a bridge plugin data type. And it's basically a function that serves as a template for the Klaster SDK to execute transactions through bridges. So Klaster doesn't have its own bridge. We are fully committed to 100% neutrality with Klaster. So it's very important to us that we support every smart account provider, every blockchain, every bridge. And how you do this? So basically, this function exposes some things like data.account, amount, destination chain ID, destination token, source chain ID, and source token. What you do here, and this function as a return value, basically it expects a bridge plugin result, which is a series of steps how to bridge. And what you are actually building when you are building a bridge plugin with Klaster, you are building a template for the SDK, which it can use anytime it needs to bridge anything. So let's see it in across, right? So as an example, so bridge plugin across, basically you can go to across docs and you can see with across how to use their API in order to encode a bridging action with across, right? So this is something that I can basically use this tutorial. So initially, what we need to do, we need to get suggested fees from across. This is how across works. This has nothing to do with Klaster, but Klaster is integrating across as a plugin, so we need to work it like this. So we need to call the across API, get suggested fees. So it says source token, destination token, and remember, these are all fields which are exposed to us by the bridge plugin type. And these will be injected at runtime by the Klaster SDK in order to generate custom bridging actions when the SDK needs those bridging actions. And this completely removes the burden of encoding the bridging actions from the developer onto the SDK. And so all of these fields, data, source token, destination token, source chain ID, destination chain ID, amount, etc., and basically you get this function and across, so we call it here, it will give us this fees response. And what we do now, we say, okay, encode approve transaction. So this is also a helper function in the Klaster SDK. We like to have as many of these helper functions so that you don't have to go around, finding things in the SDK. This simply encodes an ERC20 approve to the across spoke pool address. So this is something that the across API returns you. How much you are sending is provided to you by the data field, the amount it's injected by the SDK when it tries to bridge something. So all of this is available to you, and who basically which token we are bridging. Then we call the raw transaction with response with this encode call data, which is a function that we've written here. Basically, this function does is it parses the ABI of the across bridge. It fills out all the data needed to populate the bridging transaction for across. You know, you have the source token, destination token. Across has relayers, and this is the thing that I was fixing. It sometimes doesn't work properly with. So if some of your bridging transactions start failing in the hackathon, try playing around with this fill deadline. Sometimes it works good, sometimes it doesn't work properly. So basically, if you put it at a bigger deadline, then it will always work. But then basically, you will get maybe a little bit worse spreads from the across SDK. So you can use this. Basically, and then I was kind of going in a bit on that. So basically what you do here is you encode all of this data, put it in a simple data field, and just as before we were encoding our interchain transaction, we just return simply a series of steps for the cluster to execute on multiple blockchains. Received on destination, basically the across documentation tells us how to calculate how many funds we will receive on the destination, and we just simply put this as the output amount. So now, basically, when I call this across bridge plugin here, the encode bridging ops will inject all of the necessary bridging actions. It can be multiple bridging actions. It can be 5, 6, 7, 10, 50 bridging actions in a single calculation here. This will be calculated to you by the SDK, and it will call this across bridge plugin for every single one of them, and then it will get all of the necessary transactions which need to be executed to bridge all of that data where you want it, and it will just return to you this dot steps, which contains all of the transactions that you will ever need to bridge everything to wherever you need it. So yeah, this is basically where I'll kind of stop now. It's been already 40-ish minutes of me talking, but this is essentially how you build these chain abstracted applications with Klaster. So any questions, happy to answer or chat a little bit on what can be done. But as I can see, thank you, Philip. Philip has taken care of a lot of things here. All right. Yeah, you can check out the multi-chain disperse app. However, just know that this app was built like a day or two ago, and it's a demo app. So I'm still working on it. It'll probably need a little bit more time. It might fail, like certain things are not supported, but definitely you can check it out, play around with it. I would suggest only working with USDC, because right now USDT is kind of broken, and try only working with Optimism, Arbitrum, and Base. This has nothing to do with Klaster. Klaster supports everything, but it's just me building that application with other things. It kind of got demoted to a lower priority. Klaster is working on non-EVM support. So the question was, will Klaster support non-EVM chains? Klaster is working on adding Solana support. So we are hoping to get that, I would say Q1 25. And the core idea of Klaster is to become a chain-agnostic orchestration layer on top of all of the blockchains, where you can simply sequence transactions across multiple blockchains and then build these multi-chain applications. And even we are adding now, one of the next modules that we are adding is this cross-chain composability module, where you will be able to use the output of one contract on one blockchain as the input for a function on the next blockchain. So yeah, so like we like to say, what Kubernetes is for Web 2, this is what Klaster aims to be for Web 3. So like a proper orchestration framework where you can do a lot of things in the future. So this is like far future now. We also want to support time conditional stuff. So like do something every 20 minutes or wait 1 hour to do something, etc., etc. So yeah, essentially I think this is basically it for the demo. I hope it was reasonably clear.
It was lovely. Thank you, Mislav, for the demo as well. Thank you,
Thank
everyone in the chat as well, for being so active. And we will see you on Monday for the second to last workshop before the hacking weeks. Great. Thank you, everyone.